So good morning, everybody. Welcome to this last day of the RTR conference. My name is Monica Giannini. I'm working in CINEA in Horizon Transport Unit. So welcome to this session, EV charging solutions, get the users on board. So why we do research on get the users on board? So you have probably followed some sessions in the previous days, and that's also the main focus of this conference about scientific and technological innovation. You have seen innovation in technology enabling electric vehicles. So towards this goal that is transition to electrification of road transport. And we talk about technology and scientific innovation on components, on e-powertrains, also light material. We talk about the batteries, that's one of the main components that needs further research. But there is also another important aspect. It's not the only part of this big change. It's a big change, and that's why it needs a holistic approach. And users are an important component. So when we talk, for example, we hear a lot about range anxiety. It's not only, it cannot only be overcome by better capacity of batteries. It's also about the perception of users, the perceptions about the availability of recharging points, availability and how long it will take to recharge. So it's a complete change in behavior of users. So this is the reason why the Commission is funding projects on users' perspective, in order to see what are services needed, what are new business models that can be built around electrification. These projects that you will hear about today are projects talking about electrification, dealing with electrification, but from the user's perspective. So it's about the behavior of users, it's about the engagement of stakeholders from users, citizens, but also public authorities, because they need to know probably where do we position recharging points, what is the impact on the grid, the electricity grid, for example. And in these projects, as you will see, these projects have developed a methodology, an approach to user engagement. And you will see different demonstrations and pilots that they have done. We have 3 projects, user key and e-charge for drivers, still ongoing towards, let's say, approaching the last part of their implementation. So we will hear from the speakers what they are doing now in terms of pilots and demonstration on electrification. While the last project that we will hear is MEISTER, that finished a bit ago, some time ago. So we will hear about results from the project. So this session will be as the other sessions that you have probably followed. So it's divided into 2 parts. The first part is presentations from the speakers, and the second part, with the support of expert Evangelos Karfopoulos, will deal with your questions and will be the time for you to ask and our presenters and experts to provide answers. So unless you have really something burning during the presentations, please keep your questions for the second part of this session. So I don't want to steal more time. So we start with the first speaker, Maria Tomas, who will present user key. Maria Tomas is an industrial engineer and now a project manager in smart mobility and transport in ETRA, Gruppo ETRA. And she focuses on innovative projects for sustainable transport, smart and inclusive mobility, socially aware traffic management. We discussed about this a little bit this morning. That's quite interesting. And user-centric mobility solutions. So, Maria, the floor is yours. Thank you.
Thank you, Monica. Good morning, everybody. My name is Maria Tomás. I work as a project manager in ETRA. For those who don't know us, we are a company based in Spain. We are technology providers for infrastructure in cities, mainly in the fields of mobility and energy. In this project, we are the project coordinators, and as well, we are the developers and the product owners of two of the solutions that are being deployed in the project. To give you a little bit of context, user T, as Monica said before, is in the demonstration phase, is implementing the solutions in the demo sites. It's an Horizon 2020 funded project with 24 partners from 6 countries. We have 5 demo sites in Barcelona, Berlin, Budapest, Rome, and Turku, and we have 2 follower sites in Murcia and Florence. The objective of user T is providing a set of solutions for the charging infrastructure, for the different elements of processes through the charging of an electric vehicle. And the most important part is that we are focusing on the user perspective, or following a user-centric design, which implies the understanding of the needs, of the barriers that the user have at this moment at the time of charging an electric vehicle. So, this is the first slide.
Oh, okay. So,
Yeah.
thank you. Sorry.
Welcome. Yeah, before entering into the project, the context is very different from the time on where we started the project. We started in 2020, at the beginning of 2020, where electric vehicles were starting to exploit, but now the reality is that we have plenty of vehicles, of electric vehicles on the roads. In 2021, over 16.5 million of electric vehicles were on road. And Europe is not behind of this race, is leading this competition or position on electric vehicles. In 2021, we reached the world highest electric car penetration rates, with 5.5 million of electric vehicles in the European roads. And if we look at the figure on the right, we have different realities in the different countries. For me, the most important part is that there are different needs at this moment, or there is no one solution that fits all, at least at the same time. Are countries that have very high penetration rates with high number of charging points, but there are other countries that are starting, or maybe the price is still a commercial barrier or an entrance barrier for buying an electric vehicle. But in any case, we think this is not only a quantitative problem, and the qualitative aspects matter, and matter a lot. When we perform the user research, we got very interesting results, but there is one thing that I think is very illustrative, because even in countries with the highest number of chargers per inhabitants, the users consider in general that charging infrastructure is still an unsolved issue. So this may suggest that maybe the critical, or the charging infrastructure has not overcome the critical threshold, or perhaps there is something more. And we think, or we are sure that these other things, the qualitative things, are very important. For example, when user says, I would like to have better availability of charging facilities, it's not only about, I would like to have more charging points installed, but the thing is that if I am the user and I have a mobile application and I only see the 20% of charging points in my city, I think that there are not enough charging points. Or if when I go for charging, the charging point is occupied and I cannot charge, or I have to wait for 1 hour, I would think that I need more charging points. But this is not only the point. There are other things that can be solved through the technology and more real-time information, more diversified charging modes, intelligent charging that can help to make the investment as efficient as possible. And this is what we do in USRG. We are trying to unlock, or we used to say to unlock the massive potential of electromobility. Now I would say to boost the massive potential of electromobility beyond the early adopters. I think it's more the position that we are today. And we have 6 main objectives. The design optimization of charging networks with a user-centric approach, the development of an interoperability framework and platform, the scalable infrastructure rollout by means of smart grid integration, the development of innovative and highly convenient charging systems, the demonstrations of novel business and market models, and last but not least, provide legal and regulatory recommendations for the massive EV deployment. Here you can see the map with the USRG products mapped into each one of the demo sites. We have 5 technological solutions plus 3 non-technological solutions. Starting from the non-technological, Station of the Future is the result of the user research that provides several designs of charging stations with related business models and so on. And this is already available through, in the USRG website, so you can check the information there. Infra is the interoperability framework. We use this as a basis to develop INCAR, which is the interoperability charging and parking platform. And MOBES is a platform to share content between the different cities of the project and increase the capacity building. Then the 5 technological solutions that I will enter into more detail on each one of them in the following slides. We have CLIC, a decision support system for mobility planners that will be demonstrated in all of the demo sites, main demo sites of the project. INCAR, which is the interoperability charging and parking platform that will be demonstrated in Barcelona, Rome, Budapest, Berlin and Turku, all of the demo sites as well. SMAC is a service inside of included or integrated into the INCAR platform to provide smart charging as a service. And INSOC and INDUCAR are 2 hardware solutions. One is an integrated solar charging for light electric vehicles, for bikes and kick scooters. And INDUCAR is an inductive charging device for electric vehicles. Going into the different solutions, the first one is CLIC, the Charging Location and Holistic Planning Kit. It's the decision support system that we have created for mobility planners. It's a web tool that has different steps to describe the city, set the goals, complete it with the available data from the city, And then with this information, the tool offers recommendations about the number of charging points, the technology in the different areas of the city. This tool is already developed, but continuously improving. So now has been a first round of testing with Berlin, and BMZ, which is the company who has developed this, is making the test or some testing with the rest of the cities of the project, but they have also provided a link on which everybody can enter and try the tool. And if you see that there is something that might be improved, you can directly write Christian or to the email of the project, because from now until 1.5 months, more or less, they will be continuously improving the tool. So it can be very useful. The second product is INCAR, the Interoperability Charging and Parking Platform. This platform aims to ensure interoperability between the different charging points, between the different CPOs and EMSPs. It is based in the concept of a hub that provides OCPI 2.2. We are based in an open protocol, but in the last version that is already available, that is different from the OCPI 2.1 because it supports or creates for the first time this hub concept that we can use to connect the CPOs with the EMSPs. And apart from that, we are solving the payment process, which is also very important for the operators. And on the other side, we are providing the user interfaces for the operators and the mobile app for the EV drivers. It includes booking, routing, charging, and payment. Here you can see now the tool is completely developed. The status is that we are integrating the tool or the OCPI with the different CPOs and EMSPs in each one of the city of the project. And here you can see the screens for the operators, for the CPOs and the EMSPs. The amount of energy that has been charged, the charging point that they have in the network, but we have to remind that this is for interoperability, so the added value is that one CPO can see if a client or customer from outside or for another EMSP or external customer has charged in the recharging points. As well with the EMSP can have control of where their customer have charged in the different charging points of the different operators. Here you can see the mobile app. It's integrating the booking, the payment. In Berlin, we are integrating also the connection to the barriers, just in case we are considering semi-public charging points which require the opening of the barriers. And the app provides all the relevant information for the EV driver, includes an identity provider service to be able customers from different EMSPs logging in the app, and also have one screen for SMAC that I will present afterwards to set up preferences regarding the charging. Okay, I will be more quickly. SMAC is a smart charging as a service tool. As I said before, it's a service integrated in the INCAR platform to provide a smart charging in the cloud, let's say. In the service not specifically instantiated in one CPU, but as a service. We are including one screen, as I said before, for the user to set up the preferences, the time for charging, and the amount and the percentage of the charge that they desire at the end of the charging. INSOC is the integrated solar charging station for light electric vehicles. This solution is under developing. It will be provided by NLX and also demonstrated or implemented in all of the demo sites of the project. And it will support normal charging for bikes and inductive charging for kick scooters, basically. An Inducar is the high-efficiency inductive charging for e-vehicles. The innovation here is the small size of the device and the precision of the positioning and all of the safety issues that require such a kind of solution. Now it's deployed in Barcelona, and the users of the area metropolitana of Barcelona are starting to use these two vehicles with this technology. And yeah, this is the last slide. This is a very interesting moment of the project. We are starting demonstrations in 2 months maximum, the large scale. We are starting demonstration with friendly user next month, and in April, the large scale. Most of our solution will be in the cities that I mentioned, so I invite you to follow us on the social networks or physically in the place if you have the opportunity. And if you have any question, contact us through our channels. Thank you very much.
Thank you, Maria, for this presentation. Now we go to the second project, e-charge for drivers, electric vehicle charging infrastructure for improved user experience. We have Christina Anagnostopoulos replacing Evangelos Karfopoulos, who could not be here with us. And Christina is a senior researcher, project manager at ICCS. She's electrical and computer engineer, and she did an experience in Japan, I read. So at the University of Tokyo as international researcher in environmental engineering, focusing on renewable energy systems and sustainability. And then you continued also in Japan, so that was quite an interesting experience. And joined ICCS in 2017, focusing on transport and logistics, electrification, e-mobility and services, smart charging system, mobility as a service, automated and connected mobility, and so on. So a lot of expertise. So Christina, please, the floor is yours, and e-charge for drivers.
Good morning. I will see that works, yes. Good morning, people. I hope you're getting energized a little bit. It's a morning session. I know it's the last day, but we're talking about charging and listening to the people. We are also one of these projects, and we are now running towards the 3rd year. So in May it will be already our 3rd year. And out of the 4th year of this program. And the main idea also for e-charge for drivers is that we want to understand what are the user needs, their perspectives, their preferences, in order to use these as requirements to build the solutions, charging solutions, but also services that are interoperable, and really support the growth of electromobility in a sustainable way in Europe. We are a consortium of 30 partners, out of 12 representative countries of Europe. They really capture the whole difference of the maturity level of e-mobility across Europe. And we're focusing on 10 demonstration and pilots. So pretty much the objectives is that according to the user needs and their requirements, we are improving and designing these solutions based on those in order to become more user-friendly and help improve the charging experience. Of course, these solutions need to be interoperable, so we are also basing our systems and solutions and services in standards and common protocols. We also support this acceleration of the deployment for the charging infrastructure through the pillar of providing services such as decision supporting tools, through our charge point location planner and the tariffication schemes and the incentives overview that we're doing. So there are three main pillars, three main axes that our approach is focusing. Of course, it has to do with the infrastructure. So we're building 2 different charging stations. I will come into details in the next slides. And we're also focusing on the battery swapping systems and concepts for enabling battery as a service. The other pillar, of course, we need to provide also services for the users and also for the people involved in the stakeholders of the mobility. And this has to do with enabling concepts like plug and charge, booking services, router, and smart charging services. And as well also target the CPOs and the local authorities and provide them with tools that they can use in order to plan. Their location for the chargers and to plan their pricing policies. And depending on their regulations and what problems they're facing and they want to resolve. This would be an overview of our demonstrations. There are several pilot sites that they are addressing several use cases. We're having metropolitan areas, so more for the inner city testing. But also in longer trips in Austria, Greece, Turkey, and Italy, and along the TEN-T corridors. Of course, we had to listen to the users. This was the first thing that we put our work into. We did an a priori user survey. This was about 3,000 eligible responses that we received. And here we wanted really to see several aspects to ask the users that were not only users that they had the experience of an EV, of electric vehicle, but also light electric vehicle users or even non-users, that they would be potentially using electric vehicles in the futures. So the main reasons for choosing an electric vehicle, it had to do with being environmental friendly, and the energy efficiency and having lower operating and maintenance costs. The charging frequency, it had to do with anticipating the next trip, when you were having a low threshold on your state of charge, and also when there was a possibility to charge. Mostly of the respondents, they were having the option of the home parking, home charging. That would be approximately for a duration of 12 hours. But in general, the duration of the charging stations would be from 45 minutes to 3 hours for the slow charging and from 30 minutes to 1 hour for the fast charging. We've also questioned the charging operators, and we've seen that in terms of occupancy of the station, there was a variation. Mostly it was about 9% that the stations were being used, but there were some options, some cases that they were reaching the 32%. So this is still a low rate of occupancy for someone that is looking to invest in this type of infrastructure. Of course, the users were preferring fast charging and smart charging support, and they were willing to pay more for this. And this is logical because this is something that they can really compare with the refueling process of a conventional vehicle. Other thing we find out was that 70 or maybe 80% of the respondents were male. So it is really something that we should consider and to target more a gender balance in our service also, but also in this type of projects. I will get you through the several solutions that we have developed. Most of these are already the technological solutions, the chargers and the services, they are already fully developed. Some of those are already in the pilot phase since summer. And still, this is the time where we are entering the main phase of our demonstration and pilot. So some last verification work is still remaining. So here you will see two charging stations. The first one is a DC fast charger. This is a modular solution, so it can be easily modified, and it comes in a container. So this also means it is very easy to be transferred and placed within the urban context with no serious civil works. And it supports plug and charge, and it has enhanced user interfaces to display all relevant information, and it also offers capabilities for reservation of the charge point. The second one is it's a multi-station, let's say. This is separating a little bit the power electronics from the charging interfaces, so it gives a little bit of flexibility. It has multiple inputs for energy supply, so it can get its energy either from the grid or choose local resources. Either this would be renewable or storage. And be able to charge different type of vehicles and in different type of sessions. It also supports plug and charge, and this is also upgraded in order to support vehicle-to-grid capability. And the last one are the two solutions that are battery swapping concepts. The first one is made from Swabi in Berlin, and this is containing 6 different battery technologies in its department. This is also having an application and a user interface in order to be able to book, to see the availability of the batteries, also some type of monitoring services. And the second one is another solution that is more B2C, and it is a full end-to-end solution with the Scutun in Barcelona. And this is really making the battery swapping in less than 1 minute. And it is a solution that you can also take with you and charge in your home. And they're providing also their own light electric vehicles. Now moving to the services. The first one is the booking service. This works for short-term and long-term reservation. It can provide real-time information and as well as prediction of availability of a charging point, and also it involves rewards and penalties. The routing, the planner, it can provide 3 different profiles for routes, and based upon the status of charge, your electric vehicle, your preferences, your destination. And choosing your profile, it can be easily integrated into the navigator system. And this also provides real-time notifications if some charging station becomes unavailable, and then you need to make a replanning of your routing. There is also a set of smart charging solutions, and these address being able to use your local energy supply or storage from batteries, or use energy, choose to charge from green, using energy from renewable energy sources that are on site. Also be able to shift the energy according to the energy prices. So if you want to choose to charge your vehicle in a time where the energy prices are less, then this is also possible. Or also shift depending on specific power constraints that you want to implement. And there is also a predictive diagnostic service that works with the profile of the battery for that can be trained and used in every charging session in order to prevent battery aging. One other service, let's say, or solution that we have been implementing is the plug and charge, enabling the cardless authorization. Anything now that has to do with identification, authorizing a charging session comes to the level of the vehicle. It is a seamless experience for the driver, and all the information that are exchanged, this is happening in a very secured way. Added information are also provided. And we have been doing this already in IDIADA, testing the protocols with emulators. This is deployed by our prototypes of BMW and Volvo, and also the ABB and Powerdale charging stations. And here we have taken one further step, because we've realized that it's troublesome to really get into the world of implementing these protocols, and we have created an open source of the interfaces that could be made available and could help people with the deployment issues for implementing ISO 15118. Yes. Moving now to the decision support tools. The first one has to do with planning the charging infrastructure. This is a tool that has it consists of 3 different modules, let's say. It has a tool to estimate the demand, so in a specific area, make estimation of what would be the charging demand. According to this estimation and prediction, the planning tool will set out what would be the best mixture of technologies for the specific area and in the coverage that we want, and also considering budget limitations. And also it has a user interface in order to be able to visualize all this information. Also, we made, over our pilots, we've made an assessment of the tariff, of the incentives that are existing incentives schemes that we see in the different areas. We've seen some that are more widespread, some that should be considered, but for sure these should this should have 2 pillars, should also be addressing the EV, but also the charging stations. And, okay, I will be finishing soon. And then we've also did an overview of the tariffication. So we asked how they're formulating their pricing policies. And out of that, we have made a generic verification formula for being able to set your tariffs depending on different parameters, because this is a complex thing to answer, and it takes into account different parameters. So depending on the problem that you want to address, you may want to really change your tariffication policy that you're implementing. So this is the impact that we're trying to have here. Of course, doing the a priori survey, and we are also having the posteriori survey, we want to target the wider user acceptance. With all these tools that are helping the municipalities or the CPOs to better plan their business and enable also these different business models with the smart charging or the battery as a service, it is really helping investors to do this step forward and invest in the charging infrastructure. We will be looking into regulatory issues, and this is coming up in the next time of the project. Of course, we are basing our solutions on standards and open protocols in order to ensure the interoperability. The grid integration is also targeted through the smart charging services that we are providing. And of course, this needs to be standardized, and the same way that we're implementing plug and charge, the solutions, we try to be interoperable and have standardized approaches for the e-roaming, for the payments, and for everything that is related to this. Ending, I would like to finish with the synergies that we have been doing, and we plan also to continue with our sister projects. We are all here for supporting the same idea of boosting electromobility in a sustainable way, listening to the users. We found common synergy topics, and these are the user charging needs and preferences, issues on interoperability, and the tariff schemes and the barriers. So we are planning in the next time to produce recommendations and guidelines that will be focusing to the CPOs, to the MSPs, and to the local authorities. And just to mention that apart from that, we have been very much involved in a lot of joint dissemination activities with common session presentation and webinars, and common publications that we are really targeting to also produce in the next time. And that would be all from my side. You can follow us in our channels, and I would be happy to answer any questions you may have in the session of the Q&A later. Thank you very much.
Thank you, Christina, for your presentation. Last but not least, we have Angel Moya presenting MEISTER. The title of the project is already a presentation: Mobility environmentally friendly, integrated, and economically sustainable through innovative electromobility recharging infrastructure and new business models. So that's already a presentation. So Angel from Gruppo ETRA, he's industrial engineer and is working now since 2021 as project manager at ETRA, and coordinates European projects in the electromobility area. So as we said, MEISTER closed some time ago, and we will have the results from Angel. The floor is yours. Thank you.
Good morning, everyone. As Monica said, MEISTER is already... my presentation is not here, I think. No. Sorry, as Monica said, MEISTER is already finished. The project started in 2018 and finished 1 year ago. It took 3 years and a half. It was expected to take 3 years, but we had to extend the project because of the COVID, because we faced the COVID just when we were expected to start the demos. So you can imagine that the impact it had in the project, because the mobility patterns changed a lot, and we had to rethink some issues, and then was difficult to compare the results with the baseline after COVID and so on, but we achieved this, And the budget of the project was 6 million euros, and we had 11 partners. So this project is smaller than UserChi or eCharge for drivers. And we had 3 main cities from south to north of Europe, Malaga, Berlin, and Stockholm, that you can imagine also that the status of the electromobility in these cities was quite different. So we had to make some different approach for each city. And the main aim of the project was to test innovative business models in order to reduce the cost for charging infrastructure deployment and facilitate the large-scale deployment of electric vehicles in Europe. At the end, the objective of this project is more or less the same objectives that UserChi or eCharge for drivers, but the difference here was that we focus on the business models. But of course, we develop products, software products to support these business models. And here you can see the companies that composed the consortium of the project. We had 3 cities, 3 councils, and then 4 technology providers and consultancy, 3 research centers, and 1 housing company from Germany. So, well, at the beginning of the project, we detected the main barriers for the large scale deployment of electric vehicles: high cost of vehicles, low level of consumer acceptance, and the lack of charging stations. It was in 2018. The picture today is different, but we still have more or less the same barriers, and these barriers fit each other, so it is like a vicious circle, and we try to break this vicious circle with our business models in MEISTER that were focused to make more attractive for operators to install public charging infrastructure in order to make this infrastructure more cost effective, and also for potential users to use this infrastructure, making the charging process easier, convenient, and barrier-free. And for that, we set up at the beginning these targets, ambitious targets. We said to reduce by 20% the installation cost of charging infrastructure and by 40% the operational cost, increasing 15% the use of the infrastructure, and to reduce by 20% the charging price for users, and also to decrease the CO2 emissions. And we try to achieve this, including the electromobility in the urban mobility plans, sustainable plans, also promoting sharing modes, not only changing the technology, but also promoting to reduce the use of the private cars, promoting also the interoperability, and also developing and deploying smart grid services like smart charging and so on. And here you can see at a glance the 6 business models we test in the different demo sites. I will explain one by one in the following slides. First, in Berlin, we had these business models that we called Smart Park and Charge. The thing here was to improve the accessibility of charging points and parking places for electric vehicles and increase the turnover of the charging infrastructure in public and semi-public spaces. We detected that sometimes the parking places with charging infrastructure were misused. Sometimes electric cars or combustion cars were occupying the place, preventing electric cars to charge. So we installed some digitally controllable barriers that were connected with our MEISTER app, and it's simple. When you first book the charging point, and then when you arrive to the place, you select the the point, you start the process, and the barriers goes down. And then in Berlin also we implement iCar sharing system as a housing services in 2 new neighborhoods by Hebobach in Falkenberg and Mariendorf. And the thing here was to provide these new neighborhoods with this service, with an iCar sharing service that normally these business models only is in the city centers or the places like that, and we try to get these business models to the outskirts. And the result was very good. We had 2 cars in one neighborhood and 2 cars in another one. And we had more than 200 registered users, taking into account that we had between the 2 neighborhoods 1,000 tenants. So it's a good number for this number of tenants. And we had almost 25,000 kilometers used by this car sharing system. In addition, in the neighborhood was also installed a mobility display where the citizens could check not only the status of these cars, but also in real time the public transport stops and times, and also the bike system, and so on, in order to help them to choose the best environmental and economic option to move. And the result here was as good that the housing company include this sharing system in their portfolio for their next projects. And moving on to Stockholm, here we had first this delivery of home care services with electric vehicles. The thing here was to test the service with electric vehicles, because the challenge for the electric vehicles here was that for the service they had to stop 3 times daily, and they had only very few time to charge. And Stockholm was wanted to test if they could maintain the high quality level of the service with electric vehicles. And for that we bought 19 electric vehicles, and we installed 19 charging points. And the result was really good. The drivers were very happy with the experience. They could demonstrate that they can maintain the quality of the service. And thanks to this pilot, from January 2022, the City Council put an environmental criteria for the procurement of new cars for this service for the City Council, but also for the private companies that provides this service in the city. So from now on, all the vehicles that they will buy for this service will be electric. And then they wanted also to test a smart charging solution, because especially in winter, they had some capacity problems in the grid, in some nodes of the grid. And we developed this smart charging and storage platform that connected the DSO, the distribution system operator in the city, with the CPO, the charging point operator. That the thing was the objective was to stabilize the grid by managing the load between the points. And the DSO sent the request, and the platform, through some optimization algorithms, decide which points has to reduce the load. And also here we could manage more than 10 kilowatts at the same time between 22 charging points, and also the result was really satisfactory. But here we had some challenges, because, for example, vehicle to grid at the time of the project was still in an early situation, but in the next projects, our sisters projects are also working on this vehicle to grid think. And moving on to Malaga, to the last city, here we had a different approach for this e-car sharing system. The difference between Germany was that here we used the cars of the city council after the working hours. They had 4 vehicles that were at disposal of the workers after the working hours. So you can, through the app, choose the car and take the car of the city council for your own purposes. We had more than 76 users. All the users were workers from the city council. We had more than 400 trips, and we reduced the CO2 emissions, but also the use of the private cars between the workers. And also we helped to raise awareness on electromobility between some people that normally they don't know this technology. And also here you can see the results from a survey that we conducted between the users after the project. You can see that 90% response that they will consider selling their second car or stop buying a new car if the service is ongoing, is continued offered by the city council. And another answers that I think is very interesting because it's not only about technology, it's a behavioral change in their minds after the demo. So the result was very good, and the high potential of replicability of this business model is very huge. You can imagine if every city council or even private companies put at disposal of the workers their electric vehicles. And to finish, we tested also another smart park and charge approach in Malaga. In Berlin, we installed digitally controllable barriers, and here we installed an intelligent camera system that was also connected with the MEISTER app, and you can see in the app if the parking place is occupied or not, just to prevent make kilometers and waste energy and then arrive to the point and see that the place is occupied by a combustion car or another electric vehicle. Okay, so just to finish, here you can see some of the impacts. I was commenting the impacts during the presentation, but here you can see the impacts divided by environmental, technological, business, and policy sections. As I said, we got to reduce the number of of combustion vehicles and promoting the sharing mobility services, reducing the CO2 emissions, and we got to put for the first time the environmental criteria in the Stockholm city. The technology providers in the project will include the functionalities, the new functionalities that we tested in the project, like the Smart Park and Charge in their mobility apps. Also, Third, that was the company that developed the smart charging and storage platform, is in the way to commercially exploit this solution. And Hevovac, as I said, put in their portfolio the e-car sharing service thanks to the good results that they could demonstrate in the project. And Berlin and Malaga are also introducing new regulations for the parking and electromobility issues. And of course, all these impacts are quite related with the Green Deal, Repower EU plan, and also Fit for 55 plan in Europe. And as a legacy, I would like to comment these 4 things. We developed the EMEC, the European E-Mobility Expertise Center, within the project, and this platform is working after the project, so you can check the web and and see what we are doing with this expertise center. Also, user Chi, that ETRA is also coordinating, is improving the field of electromobility, but also our sister projects in CTV, e-charge for drivers, and so on. We participate with the MEISTER results in a Civitas course about charging infrastructure. And we also were one of the success stories for the Horizon Results Booster, that it is a service that helps to the European projects in order to exploit the results. And from here, I would like to recommend you, if you are managing European projects, to check this service from the Commission, because it's really, really helpful. And this is everything from my side. Thank you very much. And if you have any question, I will very happy to answer you in the round table. Thank you.
Thank you very much, Angel, for your presentation. I have a question for the audience. Who drives electric? Anybody? Oh, many. Good. So I think that's already interesting as a rate, and I think that we have seen interesting pilots and demonstration, and it's promising. So there is a lot that has been done, a lot still to do. But now it's the time for questions and answers. So I would like to ask our expert, Evangelos Karfopoulos, to introduce briefly himself, and then maybe we can co-moderate this session. You can prepare your questions, and we'll be happy to.
Thank you very much, Monica. Good morning also from my side. I'm Evangelos Karfopoulos. I'm senior researcher in the Research Institute of Computer and Communication Systems in the National Technical University of Athens. I'm also research leader in the 2.0 partners in the Pillar 2 as regards the systemic approach of the e-mobility and the development of charging infrastructure. So my first comment, of course, I would like also to thank all the speakers for their fruitful presentation. And for sure, there is a lot of material and a lot of information about new technologies, innovations, maturity level that can be used for the report in the S3. And for sure, we would like to further discuss about the challenges on these technologies that needs to be further addressed. But this time is for you. So we will start the question and answer session. Before raising any questions, I would like to ask from you to declare your name, your affiliation, and to whom the question should be addressed. We have some microphones in order to facilitate the question. I don't know where are the microphones. It's Lucy over there. That will help us. Thank you, Lucy. We have over there the first question.
Hello, good morning. My name is Marco Tella from Extremion, Human-Centric Digital Technologies. Well, I have a question for the last presentation, because you told the project started 3.5 years ago and is finished. And you mentioned some, let's say, huge barriers, in particular high cost of electric vehicle, low acceptance, and so on and so forth. After 3.5 years, do you think they are still valid, or do you think that the world is changing in this sense?
I think they are still valid. I mean, the barriers today, I mean, the prices went down, and also the business models around the charging infrastructure, but the lessons learned in MEISTER, I think that are really valid for today as well, because yeah, you can adapt the lesson learned to today, but they are valid.
Well, as far as with regard to the question that the moderator made to the audience, it seems not, because the majority of people here is already driving electric, and therefore it might be that.
I know. I mean, yeah, of course. I mean, the challenges for today is still to make people to trust in this technology, and for that we have to continue developing services around the charging to make easy, as easier as Maria said, to make charge or to have electric vehicles as easier that today is to have a combustion vehicle. But I mean, as I said also in the presentation, 2 days ago, the European Parliament voted in favor to ban combustion vehicles from 2035. So we have 10 years to continue. I mean, we have to speed up the thing, but yeah, we have to make things easier for the drivers. But, and also I would like to mention that we should to change also our mentality and try to reduce also the number of cars. Because it's, in MEISTER, for example, we tried also to promote sharing modes, because it's not only about the change of the technology, but also it's also about the change of our way to move as a whole. And we wanted also to connect this with the public transport, active modes, and so on. So yeah, I mean, there are many challenges still today to be solved, and yeah, the lessons learned from MEISTER that you can check in our handbook, in our web, are completely valid for the companies and also for all the stakeholders by today. Yeah, but there are many things still to do in that area. I don't know if I answer properly your question, but I tried.
Thank you very much. We have another question.
Okay, hello. My name is Fatih. I work for Tofaş. I'm Research and Advanced Technology Manager. In a summit, Frank Menchaca, who is the president of Society of Automotive Engineering, said that 30% of charging units in United States are not functioning due to various reasons, and that can be a breakdown or theft. Even though the applications and systems are showing that they are available. Can you imagine that? So I don't know if you have already mentioned, sorry if I didn't understand, but I wonder if you have such a statistic for Europe, and if did you or would you like to address such a problem? Thank you.
I suppose it's a more generic question that should be addressed by anyone. So whoever wishes to reply.
I think it's linked to the business model. I mean, if a service is not working, then the users will drop the service, and I mean, it's part of the business model. I don't know if you have touched upon this.
No, from my side, I don't have the statistics, but yeah, it's it's a functionality. The real-time status of a charging point is available. It's something that you can check. I mean, in Netra we are CPOs, so we know which is the status of the charging point. If there is not any physical problem with the charging point and it communicates, it shouldn't be a problem. Maybe when we move to roaming platforms, the communication should go from the charging point to the CPO and to the platform, to the roaming platform. Then the communication maybe fails, but I don't think it's a technological problem. It's more on the maintenance and operation.
I would like to add here the thing about the regulation. I think that the authorities and the regulations has to go in the direction to to control these issues. It's not good to have 20% of points out of service, so we have to promote regulations in order to make mandatory for these operators to have just few days in order to solve this problem, because if not, the new EV users will complain about this with a lot of reasons, and I think we have to support also this with regulation.
Okay, we have another question, either Mr. Maggiore or...
Yes, my name is Andreas Dorder from the Austrian Ministry for Climate Protection, Energy, Environment, Mobility, Innovation and Technology. I have a question for all of three of you concerning the vehicle-to-grid operation. I'm deputy head of the Department for Transport Technology, so my main clients for funding is the vehicle industry and not the utilities like my colleagues in the energy department. My perception is that the vehicle industry is rather skeptical on vehicle-to-grid operations simply because they are blamed when the lifetime is reduced and the utilities have all the advantages for load leveling. I mean, the argument is always that there might be some financial compensation, but my perception is that the client and the vehicle user just simply wants the vehicle completely charged when he's coming back and not some euros he would gain. So what is your experience with the vehicle industry and utilities on vehicle-to-grid operation? Thank you.
Yes, if I may add something to this, with regards to the problem that you mentioned, that with vehicle-to-grid, maybe you are afraid of not having your vehicle completely charged when you want. There are, for example, in the SMAC solution that we are developing, there is a screen in the mobile app of the user, not only for vehicle-to-grid, but also for smart charging in general, where you can mention or specify which is the time that you will leave the vehicle. For example, if you go to the cinema and you will spend 3 hours more or less, and which is the minimum percentage of charging that you desire at the time you leave. So with this, of course, there will be customers that will charge as fast as possible, but maybe not all of them. For me, the point is giving this possibility.
Yeah. If I may also add, there is, I think, in our cases, we haven't really considered at this stage the battery side or the effect that these type of capabilities will be having on the battery degradation, on the lifetime of the battery. But this is a parameter to consider. But vehicle-to-grid capabilities could offer, could unlock some market possibilities with grid-related services that could be offered from the vehicle back to the grid. But I feel that this is at very specific use cases. So, and also I do not know, the feeling that we're having from the part of the grid operators, it is that at least presently they do not really see a commercial use case coming out of that. So it should be considered for some specific use cases, but that could be now feasible to give some type of solution for that. But it's still, I think, they don't really want to depend on these flexible loads for being able to make, in terms of from the perspective of the grid operator, to be able to stabilize their system or use it here and there for different type of reasons. But for a few maybe specific use cases, this could be the case, that they could be of value, also for the grid industry.
Yeah, in my case, just to add that I agree with you, because sometimes utilities are quite reluctant to collaborate in this vehicle-to-grid test. For example, in MEISTER, we had problems with that. We wanted to involve DSO in Spain, in Germany, and Stockholm. At the end, we only could involve Ellevio, DSO in Stockholm. But just for smart charging. We couldn't test vehicle-to-grid at the time when the project was ongoing, not only because of the lack of involvement of the DSO, but also for the status of the technology at that time in the vehicle side, because as you know, only very few cars today permits the vehicle-to-grid. Yeah, but I mean, we had to work in line to make DSO see the opportunity to include flexibility services around this vehicle-to-grid technology.
Thank you. Another question, Mr. Maggiore?
Yes, good morning. Maurice Maggiore, European Commission. Thank you for the presentations and the variety of use cases. I would hook on a couple of references that I remember. I think it was user Chi mentioning them. One is this booklet with guidelines. I think they are really needed, because I see installations which are crying for being improved, even very recent ones. But are you considering in these guidelines also the needs of impaired users? Because I see installations where, for instance, they put a physical barrier in front of the column in order to avoid it being damaged. But basically this would stop, I think, someone on a wheelchair to plug in or to scan the badge or whatever. So if this is has been a consideration or not. The IEA is having a group looking into that, but maybe you have already started something. And the other point, someone mentioned, probably user Chi, but I don't remember for sure, the case of charging points behind a bar. I would make it wider, because I had this experience myself several times. I mean, you see a charging point on the map, you arrive there, and it's not accessible. Either because there is a bar, or because it's in the home of someone. I wrote to the operator and says, we have no way of knowing it and to separate this. So if you have this kind of experience, if you've thought about it, how it can be improved, because this is, I remember another case was in a hospital, so it was behind the bar, and of course it was only for people, but it was reported as available. Thanks.
Thank you for the questions. Yes, starting for the first one, yes, we are considering accessibility in general. There is not something very specific to physical disabilities, but accessibility is considered, and also gender issues. The good thing, or what we tried to show with the Station of the Future, which is the handbook, was not being restricted by the real constraints, but gather or connecting all of the requirements that we got from the users and design the different types of charging stations for light electric vehicles, for EV, for cars, in different contexts, in city centers, in the highway, so that it can be accessible, inclusive, also efficient on the way, and with the rest of the services included to promote the business model around that. So it's more a declaration of intentions with the requirement that we have, because it's not possible to build really the prototype that we would like in the different cities. So accessibility is somehow included. I don't know if in the way that you mentioned, but it's included there. And with regard to the second point, yes, it sounds to me a bit strange, because when you define the charging point and you include the charging point in your system, or you provide the information through OCPI to another platform, to a roaming platform or something like that. One basic thing that you can specify if it is public or private use. So if it is inside a hospital and there is no possibility to access, you should define it as a private charging point. And this is something that is possible. So with regard to the barrier, it's technologically possible, but there is a work behind that. You need to be integrated with the parking provider, for example, or the CPO should be integrated with the parking provider, and the app, and it depends on the EMSP or on the roaming app or app that the user, the capabilities of the app that you are using. It should, or from our perspective, it should show if there is a barrier, if the accessibility is possible, or do you need a card, or do you need something else to charge. But yes, there are things that happens, and we receive this feedback from the users as well.
If I may add, mostly towards the second part of the question, I think it really gets down to the need to have a really proper planning for making the decision to deploy the charging network in a city or in smaller municipalities. So for example, I would speak for Greece, that there has been a really huge boost for electromobility and building charging stations and incentives for EV purchase since 2019 mostly, and this has been also through law and other environmental incentives. There is no way that we can address the issue of like having a common way of planning. So how do you choose to build your charging station there, and why? It should be somehow a rule that in order for a municipality or an authority that like the energy authorities or something, to really track this type of development. So if you want to place a charging network in a municipality, you need to provide along with that a survey that says why you need it there, how many people are there, what is the prediction of your use. Do you have the people there that they are going to be buying EV vehicles and they're going to be using those stations? Where are those going to be placed in the space? And all this to be supported by surveys and data, and really put some work into the planning phase. And then I'm living in a flat. Do I just choose to build a charging station at my basement and then provide it as a business? I need to have a common understanding of the community, of my neighbors, of the people that live around me, of the municipality, so that this is happening in a structured way. And this is a way to avoid having stations that are unused, or having problems with accessibility, or having a station that is public, but somehow it happens to be inside a hospital or inside someone's house. So I think somehow there should be a regulated way to have this type of monitoring from the authorities before someone, if private or on a national level, let's say, wants to develop the charging infrastructure. This would solve really some problems that would come in the future.
If I may add something about the issue of accessibility, just to mention that some months or weeks ago I met with the Association of Disabled People in Spain, and they were worried about some accessibility issues, like the weight of the cable for the high capacity chargers, that, as you know, they have a refrigeration and the cable is too weight for some people, but also things about the software for people that have problems to you. And I know that, and they told me that they are preparing, in Spain, we are preparing a new regulation for charging infrastructure in that regard, just to mention this, because it's an important thing to take into account to make electromobility easier for all the people.
Okay, thank you very much. One more question. Can we have Lucy? A very quick, if it's a very quick question. Okay, very quick. The last question, and for sure we can have a more live discussion outside during the coffee break. In front of here.
My name is Patrick Aubergs from Mobile 21 in Belgium. I have a question about the cost structure or the pricing of charging. I think it was the second presenter that mentioned that only in one case there's a time threshold. If you compare to regulated parking, there's a principle that says when that time is money. So when you stay parked for a longer time, you have to pay more. How does it combine with your experience having no threshold on time with e-charging?
So in the survey that we did upon the tariffication schemes and how the pricing policy is developed, it's really, the pricing comes as a combination of different parameters, and one of those, it is time. So a lot of cases that the charging is happening according to the parking time. But in the general formula, let's say that we have finalized as an outcome of all this, we take into account different parameters that have to do with the time of parking, with the cost of the energy, with the cost of the infrastructure, of the installments, and with any other extra costs that they could be variated in order for the CPO to choose what will be the end price. So if, for example, you're a CPO and you're facing problems like you have a lot of time that EVs are parked on your charging point without charging. A policy there would be that then you reverse your tariffication scheme, and then you start to charge on the parking time. So if you want to don't waste the time and have the station more free, you choose to charge on the time that the car is parked there, because it's not charging all the time. And then this will reduce exactly the time that the car is staying at the station. And this can go in different ways depending on what is your problem as a CPO, as a charging point operator, and that could vary also during the period of time. It could be this week I'm having too much of occupancy, and I want to have, because of the extra parking, and I want to have vehicles coming and going, just charging what they need and go. Or I see that I have vehicles that are charging for long periods. So maybe I want to implement a different type of policy. So this type of
Sorry, no, go.
Okay. Yeah, so it really gets into playing with this type of parameters and the parking time and the cost of energy and anything that went into the charging station, let's say, financial status, in order to tackle specific problems and try to resolve things that might come up.
If I may add something very briefly to complement what Christina mentioned.
Very quickly.
Yeah, very quickly. We have called it opportunity cost for the CPO. So for each one of the charging points, the CPO can introduce the opportunity cost that can be different at different hours or at different charging point locations, depending on the use. So you can make a higher price depending on the time that the user is charging.
I think, yes, it's quite interesting discussion, and of course this can also continue after the session. And as you have seen, it's not only about technology, it's about users, it's about business model, and there is a lot to do still. So I would like to thank our speakers. Thank you very much for your presentation, and our expert, Evangelos. And I would like to invite you now to the coffee break, and grab a coffee and go to the European Commission stand to meet also the Horizon Europe projects. And then there will be last sessions of the day before the final closings. So we will have in this room innovative solutions to achieve sustainable mobility in urban areas, and in Newton, full automated infrastructure upgrade and maintenance. And in the Archimede room, materials for future electric vehicle batteries. So thank you very much for being with us today, and enjoy the rest of the conference.